Good morning, all of you. Today I am giving a lecture on Norton's theorem, and this is also the continuation of my last lectures. Norton's theorem. It is myself Sweta Bijali Maity, assistant professor from Haldia Institute of Technology. As I have already given the lecture on Thevenin's and the superposition, this Norton's theorem, it is a converse of Thevenin's theorem. Converse means it is in Thevenin's theorem, and equivalent circuit consists of voltage source in series with a resistance. But in Norton's theorem, equivalent circuit consists of current source in parallel with a resistor. That's why Norton's theorem is a converse of Thevenin's theorem. Then, what is the statement of Norton's theorem? Any linear active bilateral network having a number of voltage sources or current sources with resistances can be replaced by a simple equivalent circuit having single current source IN in parallel with a single resistance Rn, where IN is known as the Norton's equivalent current or short circuit current through the terminal AB. AB means the open circuited terminal or the short circuited terminal. And Rn is known as Norton's equivalent resistance viewed back into the network from the terminal AB. Next, the steps. What are the steps for calculating IN, means the Norton's equivalent current or short circuit current, and Ra, Norton's equivalent resistor? Then first step, calculate Norton current. What is the step? First step, remove the load resistance Rn. Remove the load resistance Rn. If I not understand which one is the Rn, then through which current is required, that is the Rn. Through which current is required, that is Rn, and short circuit it. First remove Rn from the network and short circuit it. Then step 2, find the current through the short circuited terminal, and this current is the short circuit current and also known as the Norton's equivalent current. In the next step, calculate Norton resistance. This is same as Thevenin's resistance. So before calculating Rn or RTH, set all the independent voltage sources short circuit and current sources open circuit. So why all the voltage sources should be short circuit and current sources open circuit? Then again I repeat, voltage sources short circuit because in short circuit allow the current, but in across the short circuit voltage is 0, and current sources open circuit, that means in open circuit current is 0 but there is a non-zero voltage. That's why after removing all the voltage and the current sources from the network, calculate resistance Rn viewed back into the network from the open circuit terminal. Suppose that open circuit terminal name is AB, that I have already mentioned in statement. This resistance is known as Norton's equivalent resistance Rn. So after calculating IN and Rn, draw the Norton's equivalent circuit. So draw equivalent circuit, and that equivalent circuit consists of Norton's equivalent current and in parallel with Norton's equivalent resistance. Replace the entire network by Norton's equivalent current in parallel with Norton's equivalent resistance, and connect the load resistance Rn. That means again reconnect Rn, and reconnecting Rn, calculate the current through the load resistor. Then next, this is the equivalent circuit, that is linear active bilateral network, and this is the Norton's equivalent network. That network having one current source in parallel with Rn, and then Rn is the load resistor. And after reconnecting Rn, calculate In here. This is the statement of Norton's theorem. Now the explanation. This is the general explanation. For understanding the statement of Norton's theorem, first I want to explain that network. That network having one voltage source Vs and consists of 3 resistor, 4 resistor, R1, it is R2, it is R3 and it is Rn. Then step by step apply the steps for calculating IN and RN. So for this given network, first identify RN. So as it is mentioned here RN, so it is your RN. So first step is remove RN from the network and short circuit it. So again redraw that circuit by removing RN. It is R1, it is R2 and it is R3. It is Vs. Now after short circuit it calculate ISC or IN. That ISC is nothing but IN. So before calculating ISC, calculate the total current flowing through this circuit. So first calculate I. So I is equals to what? We know the Ohm's law. I is equals to V upon R. V means Vs and R means the equivalent resistor. So what will be the equivalent resistor? If we consider that current flowing through R1 and that current flowing through R3 and again R2. So from this current direction we can understand that R2 and R3 connected parallel and that parallel combination series with R1. So Vs upon R1 plus R2 R3 by R2 plus R3. This is the total current. After calculating total current, calculate how much current flowing through that particular short circuited part. That will be ISC. So ISC will be equals to, here current divider rule is applicable. Current divider rule is what? Total current I multiplied by opposite resistor. The resistor is R3 and divided by the total resistor R2 plus R3. This is ISC. And that ISC is also known as the Norton's equivalent current, IN. After calculating IN or ISC, calculate RN. So before calculating RN, remove all the voltage and the current sources by their internal resistances. So how we can remove? Voltage sources by short circuit and current sources by open circuit. So again redraw that circuit as network having only one voltage source. So voltage source should be short circuited. their open circuited terminal is AB. Now viewed back into the network from the open circuited terminal for calculating RN. It is R1, R2, it is R3. So how we can calculate? Always equivalent current calculated by considering a current. If we consider a current flowing through R2 and that current flowing through R3 and R1. So R2, R1 and R3 is in the parallel and that parallel combination series with R2. That is the equivalent resistor. That is the Norton's equivalent resistor. So Rn will be equals to R2 in series with the parallel combination. R1, R3 by R1 plus R3. This is Rn. So after calculating Rn, draw the Norton's equivalent circuit. That equivalent circuit having one current source in parallel with Rn and again reconnect RL, load resistor. This is the Norton's equivalent circuit. It is IN, RN and it is RN. So after drawing Norton's equivalent circuit, calculate IN. What will be the current flowing through the load resistor? So IN, here also the current divider rule is applicable. So IN will be equals to the total current already given, IN multiplied by opposite resistor will be Rn divided by the total resistor Rn plus Rn. This is the current through the load resistor. And these are the procedure how to calculate short circuit current or Norton's equivalent current and Thevenin Norton's equivalent resistance, that is same as Thevenin equivalent resistor, and then the current to the load resistor. If I discuss one example, then all of you understand how to calculate IN and RN by using the steps, different steps. Find the current to 3 ohm resistor by network for the network shown in figure. This is the network, that network having 12 volt, 24 volt, 12 volt, R1, R2 and R3. Find the current to 3 ohm resistor. That means that 3 ohm resistor is the RN. So what is the first step? First step, remove that R3 from the network and short circuit it. Remove that R3 and short circuit it. After short circuiting, calculate IN. How to calculate IN? Actually, as this network having the two voltage sources, 24 volt and 12 volt, so the current flowing through due to the 24 volt and due to the 12 volt, so IN will be equals to, if it is I1 and it is I2, so IN will be equals to I1 plus I2. So from this network it is very clear, I1 will be equals to what? 24 by 6, R1 is the 6 and I2 will be equals to 12 divided by 1, so it will be 16 ampere and this is the IN or ISC, Norton's equivalent current or short circuit current after removing RL and short circuit. Current will be equals to 16 ampere. Then calculate RN. So before calculating RN, remove all the voltage sources from the network. So if we draw the network by removing the voltage sources, as this network having two voltage sources, so two voltage sources short circuit it, and RL removed, and it is open circuited. So from this open circuited terminal viewed back into the network. If we viewed back into the network, then it is understood that 6 ohm and 1 ohm resistor is in the parallel connection. So Rn will be equals to R1 R2 by R1 plus R2. It is very simple, and 6 into 1 by 6 plus 1. So it will be 0.857 ohm. That is the Rn. So after calculating IN and RN, calculate or draw Norton's equivalent circuit. And this is the Norton's equivalent circuit. That is IN 16 ampere and RN 0.875 ohm. Now the last step, calculation of current through R3 and reconnect R3 to Norton's equivalent circuit. Calculation of current through R3. So calculation of current through R3. Here current divided rule is applicable. So IL will be equals to what? Total current multiplied by RN, opposite resistor divided by the total resistor. RN plus RL. Here RL means the R3. So it will be 16 into 0.857 divided by 0.857 plus 3. That will be equals to 3.55 ampere, and that is the answer. Current through the 3 ohm resistor. I think all of you understand how to calculate IN and RN from this example. Then again, I want to discuss another example. This is another example, that network having the 1, 2, 3, 4 and 5 resistor. Now, question is calculate current through 2.5 ohm resistor. That means that 2.5 ohm resistor is the RL. So first step, remove RL from the network. That means remove 2.5 ohm resistor from the network and short circuit it. After short circuiting, calculate IN. So again redraw that circuit. It is 20 volt, it is 4 ohm, it is also 4, it is also 4 ohm, it is 5 and short circuit. Now calculate the short circuit current ISC. So before calculating short circuit current, calculate the total current or supply current or circuit current I. I will be equals to what? I will be equals to the V upon R. V means 20 volt and the equivalent resistor. Equivalent resistor means that current flowing through 4 ohm, then flowing through 4 and that 4, but not flowing through that 5 ohm resistor, directly flowing through the short circuited part, because current always follow the low resistance part. So bypass that 5 ohm resistor. So what will be the equivalent resistor? That is 20 divided by here 4, and that 4 and 4 connected in parallel, and that parallel combination series with that 4 ohm resistor. That means 4 plus 4 into 4 divided by 4 plus 4. And this is the total current. And that total current will be equals to 3.34 ampere. that is 20. That's 8. 8 multiplied 4, 32, and 16, that is 48, divided by 8, that means 6, and 20 by 6, that will be 3.34 ampere. It is total current IN, it is not the ISC. Now ISC or IN, ISC or IN will be equals to total current I, that is 3.34 multiplied by the opposite resistor 4 divided by the total resistor 4 plus 4. Now it will be 1.67 ampere. It is ISC. So after calculating ISC or IN, calculate RN. So before calculating RN, remove all the voltage sources and the current sources. As this network having only one voltage source, so only remove that voltage source by short circuiting. RL. It is 4 ohm resistor. It is also 4 ohm resistor. It is also 4 ohm, and it is 5 ohm resistor. So for calculating RL, if we consider a current, then current flowing through first 5 ohm, then again 4 ohm, then again it will be divided in 4 ohm and 4 ohm. That means what? That 4 ohm and 4 ohm connected in parallel, and that parallel combination series with 4 ohm, and then total combination parallel with 5 ohm resistor. So Rn will be equals to this is the Norton's equivalent resistance for that network. That will be equals to what? Parallel 5. That will be equals to 48 by 8 parallel 5. It will be 6. So that will be equals to 6 parallel 5. Six parallel 5, that means 6 into 5 divided by 6 plus 5 will equals to 30 by 11, and that will be equals to 2.73 ohm. and this is Rn. So after calculating Rn, draw the Norton's equivalent circuit. And again reconnect RL. IN 1.67 ampere and RL 2.73 and RL 2.5 ohm. Now calculate IN, current to load resistor. IN will be equals to total current 1.67 multiplied by opposite resistor 2.73 divided by the total resistor 2.73 plus 2.5. 0.73 plus 2.5, and that will be equals to 0.87 ampere, and this is the answer. Current through the load resistor or 2.5 ohm resistor. I think all of you understand how to calculate IN or short circuit current after removing RL from the network, and how to calculate Norton's equivalent resistance after removing all the voltage and the current sources, and how to calculate IL, current to the load resistor, from the Norton's theorem. And that's all. And thank you all of you, and meet you again.